problem 23, we are given data that reflect your annual salary for the first 4 years of your current job. So the input quantity is time, variable T in years. Output quantity salary S in thousands of dollars. So be careful with these numbers for output. Part A, identify the vertical intercept for the function S of t, write it as an ordered pair, and interpret its meaning in a complete sentence. The vertical intercept is 0, 20.1. We can read that from the table here. And to interpret its meaning in a complete sentence, your starting salary at your current job was $20.1 thousand or $20,100 written out. For part B, determine the average rate of change for S of t during this 4-year time period. Write a sentence explaining the meaning of the average rate of change in this situation, and be sure to include units. So my average rate of change over the 4-year time period, I'm going to look at the first ordered pair and the last ordered pair to compute my average rate of change. So difference in outputs, 22.1 minus 20.1, divided by difference in inputs, 4 minus 0. This gives us 2 over 4, and I'm going to go ahead and write that as 0.5. The units on that are units of output, which are thousands of dollars per units of input, which is years. So I'm going to multiply that out. So 0.5 times 1,000, that means $500 per year. So in a complete sentence, the average rate of change can be explained this way. Your salary during the first 4 years of your current job increased at an average rate of $500 per year. Part C, verify the data represent a linear function by computing the average rate of change between at least 2 additional pairs of points. So I'm going to do this on the interval from 0 to 1 and the interval from 1 to 2. Pause the video, try to do these computations on your own, and then double check when the video restarts. So the computations then on the interval from 0 to 1, we're going to take the difference in the outputs, 20.6 minus 20.1 over 1 minus 0. If we compute, we get 0.5. On the interval from 1 to 2, 21.1 minus 20.6 is the difference in outputs over 2 minus 1, the difference in inputs, also gives us 0.5. And you can see that if you look at the interval from 2 to 3, the outputs are different by 0.5. Same thing on the interval from 3 to 4. So the AROC values, average rate of change values, are equal. Therefore, S of t is linear. And for part B, we want to write the linear function model for the data. So we're going to start with our proper notation, S of t equals. We need our slope, which is our average rate of change, 0.5 times our variable t plus our vertical intercept, which is 20.1. And there we have our linear function model for the given data.